What I'm going to walk through now is how Sphinx can deal with multiple databases within a single kind of query. We think that in most realistic data organizations, your data is not going to be in one place, at least two places, maybe more. And for your AI to actually be a good partner to you, it needs to be able to navigate that as well. So no need to ETL it into one place. The way we moderate this is through our Sphinx rules. You basically need to tell Sphinx what data sources exist, and then it should be able to navigate them on its own. So I'll walk through how that works. Here I have two different data sources. I have a local database, which is SQLite based, and I also have Snowflake on the cloud, which of course I provide a token and a username and tell it how to connect there. All you need to do is specify this in natural language. Sphinx can figure out under the hood how to actually implement those connections. Having done that, we can now proceed to asking a question. So here we're going to do some relatively straightforward analysis of well, at least what looks like relatively straightforward analysis of some data on products and reviews. So my product catalog is local, so I'll say, can you go pull the product catalog from the local database, and then also go pull reviews, a larger data set, of course, from Snowflake. Realistic setting, the reviews might be collected by some kind of service that writes it to Snowflake. And then tell me which products broken down by the top level category seem to have the most decline in review, the biggest decline in average review from, I believe this data set extends to middle of this year, so from Feb 25 onwards versus prior to that date. So before Feb 25. We'll fire this off and let Sphinx begin to work. And now it's starting to figure out how to first manipulate the local database, and see it's looking at the schemas, it's looking at the tables, and it seems to have found what it wanted. Now we're going to go into Snowflake, dig in Snowflake. Of course, it tried looking for just like a table called reviews, which of course does not exist. It's called something like raw review or something else, and it has now eventually found the right thing. We don't claim to one-shot this, right? Like if there's maybe a semantic layer, we could leverage that, but for your real raw data, we will actually go look for it and find the right answer. And we found it, we've identified what the column types are, etc. And we've pulled in some samples of this data to kind of understand it. Now, what we found here, of course, is that there's a bunch of missing values and that we've asked for a date filter. And what's interesting here is there is no date column. Actually, the review metadata is a string which kind of describes reviewed in the United States on March 6, 2025. That's fine. Sphinx has context on your actual data. Right here, it's text. If it's numerical, it also has equally good context, and it's able to then say, okay, I need to build some additional code to do the filtering. The other thing, of course, that you may have noticed is that the IDs on these tables are different. One is called like product identifier. The other one's called ASIN. So doing the joins across this also by building data set level awareness, we can get that. So we're able to write this join. Well, actually, it seems like it made a mistake because of that exact column issue. It's changed the columns, figured out how to do the join, and now the data is all in place. We'll actually find that there's a bit of a trick to this question. All of our products are actually in the same category, and so there's actually no useful information here. This is where you might expect a Copilot to stop and say, I've done my job and I give up, but really Sphinx will try eagerly, unless you obviously prompt it not to find an answer that actually gets at the heart of the question you're asking. So here it's going to say, maybe I'll do granular product ASIN level. There are not that many ASINs that are being sold in this data set, so let's just go down one more level so you can actually visualize the data. It's going to start writing queries for that. It seems to have some kind of like Python library issue. Totally fine. You look at your environment. It seems to have dumped out some information now, which it'll be able to use. And now it's going to be able to give us a summary of what we found, which is that there's only one top level category. We've looked through it, and then there are certain products that seem to have the biggest decline. It does give us some warnings around small sample size, but let's push forward past that and say, actually, could you help me visualize this? So please make me a bar graph that shows like the per product decline, and then we can visualize which products seem to have the biggest decline as kind of a conclusion to this analysis. Obviously, this is now easy, so it can go build this graph, deal with all the graphing code, and we have found that we can see what products are doing worse now. Seems to be certain women's clothing, men's boxer shorts, whatever it might be. And now we're ready to go with further analysis. I'll stop here in that the data is now joined and ready to ask your questions to. But Sphinx can really operate across very wide ranges of data. It doesn't matter what type of data it is, doesn't matter if the schema is neat, doesn't matter if the information is buried in some kind of other hidden structure. We'll deal with it the same way that you would do it yourself, except with a lot less manual effort.